welcome at the second webinar for the Healthy Building Design Competition 2025. My name is Lada Henset-Centnerova. I am one of jury members, and I am also one of RIHWA vice presidents, and I am also, if I may call myself, expert on thermal comfort. So I may start with this webinar, and second speaker today will be Ulla Haveringer. She's also here, and at the end, then if there will be questions, we can answer questions. So as I said, today is a second webinar, and its agenda is indoor environment quality and health in schools. We divided it in 3 parts, more or less: climate change and indoor environment quality, indoor air quality, health and academic performance, and then other issues. So first of all, what is indoor environment quality in buildings? Just to be on the same line, then to start with, I would like to here show you that, what we see indoor environment in buildings is actually influenced by outdoor, influenced by buildings themselves, by building systems, and by people. So I will start here about, I will start with outdoor. We live nowadays in a period when climate change is getting more and more obvious. Everybody gets confronted with it, and we have to adapt ourselves and our buildings. Our landscape are changing, weather conditions, and actually HVAC systems. We have to adapt to it. So I search on internet just to find some few words, headlines. If it's true, does climate change influence indoor environment quality in schools? And actually, I found one headline from August this year, which is related to schools in Italy. You are going to design school in Italy. I don't know in which part it is, but it's just to show as an example that it's problem. It's problem from actually climate change, overheating, also in schools. So what can we do about it? We have to adapt. So you are actually joining here Healthy Building Design Competition, which is organized by RIHWA. And I'm not sure if you all know it, but RIHWA is a European Federation of National Associations of HVAC engineers. HVAC, heating, ventilation, air conditioning. So knowing that, maybe you would think that you have to make your design which has as much HVAC systems as possible. But that's not the case. We are looking for innovations, for new ideas in renovation of school buildings, where you have actually sustainability, inclusion, and beauty on your mind. I would like to take you now quickly through this list of possible adaptation strategies in HVAC design. You can, of course, use another strategies. Here on my list, everything which is related to HVAC is blue. And actually number 9, active cooling, is of course also related to HVAC, but I just think that you should design schools without using active cooling. So let's go quickly through this. So first, adaptation strategies related to buildings. You know it. One of consequences of climate change is urban heat island effect. And actually, I don't know if you heard about that, if you learn it at university, that actually first time which was referred about urban heat island was in 1799 in New York, where Noah Webster reported 0.8 degree difference between year mean temperature between New York and rural areas. Of course, nowadays these differences are much bigger. I live in the Netherlands, and here actually the year mean temperature difference between big cities and rural area is 3 degrees, but on day basis in summer can be even 7 degrees. So of course, then you should take this into account in your design. And this is what you can do, to start with the direct surrounding of your building, and to have the possibilities of, let's say, trees which give shade in the summer, but let the sun shining through the winter. But yeah, I think you know this. Another, if we look at the building constructions. So we all know that old massive buildings are also in summer very nice, cool. I took here the most extreme example I found, which is Sarkassa in Turkey. And so these heavy, massive old buildings are cool inside, even in summer, because of that large thermal mass, which acts as a heat storage, or if you would like, a battery. On the other hand, in light constructions raise temperature very fast and even above the outdoor temperature. And here again, extreme example of just tent. So heavy construction seems to have advantage, but it is actually not always possible or desired to realize heavy construction. So it is well possible to create a similar effect in light constructions with applying phase-changing materials. And PCMs, they can have the ability to store at least a large amount of energy in the form of latent heat. So that's yeah, another possibility. And then with climate change and changing buildings, we have a problem which is related to still growing stronger norms about insulation and airtightness. So I'm not sure how is the situation in your country regarding that, but I think it's yeah, everywhere in Europe that yeah, buildings are getting more tight and airtight, and which actually this of course is reducing heat loss through building envelope, but that is very good for winter. But then if we don't have other precautions, then we get problems in summer. And the solution for the problem I just meant can be a good functional ventilation, or even also a higher airspeed indoors. I am now not speaking about just the standard ventilation, which has to maintain a good indoor air quality, but I mean also like to use natural ventilation, which can be caused by two natural forces. pressure differences or temperature differences, or even combination of both. So here again, like some extreme examples of natural ventilation and also fast air movement, airspeed, higher airspeed with using ceiling fans. And then we are coming to another problem, which is actually mostly in countries with a mild and cold climate. And that's actually windows if they don't have any shading possibilities. They so again, I already mentioned I live in the Netherlands, so example from the Netherlands. There's always actually a very strong feeling in the architecture in the Netherlands to have enough daylight in the houses, also as for schools. And actually in the 19th centuries, there were houses in Netherlands built with less but bigger windows. The reason here behind was the window tax, which was introduced already by Napoleon in 1812 and stopped after 84 years. But since then, the large windows are very popular until today. And but of course, you have to take into account there must be a balance between sufficient daylight, view, privacy, and yeah, unwanted solar radiation. Then another adaptation strategy or problem from my list I showed you at the beginning is heat production from people and appliances. And I know in primary school is this problem less urgent. It is not like at the university where all students are sitting with laptops. But nevertheless, I found an illustrative photo from a primary school where all kids have a laptop. But oh yeah, here this is not so big problem. Another thing is which I tell to my students is that you have to take into account by design expectations and previous experiences. So here example of schools which I looked on internet. Actually, most of them are supposed to be in Italy. So of course, if you go to a very old, massive building, somehow you expect a little bit different environment than in very light new building. So yeah, all this is here related. And then the last of my list is what you have to take into account, what you have to deal with is behavior and personal control. And here this morning I let my personal IE assistant make these two pictures of class at the primary school just to illustrate that behavior and personal control in primary school, it's here it's very much related to one person, and that's a teacher. So here it's very specific case. You don't have people or pupils here. They cannot adapt themselves except just to take off a sweater, but there is the boss as the teacher. So this was just a short, quick introduction what you should take into account redesigning school in particular. And now actually we come to part indoor environment quality in schools, and Ula is going to take over. And you are muted.
Of course. Well, thank you, Lada, and good afternoon from my behalf. I'm Ulla Haverinen-Shaughnessy. I'm professor for good indoor and building health at the University of Oulu, Finland. And I'm a civil engineer from my background, also including environmental health in my studies. And I perhaps have like more of a research perspective on this topic. I have been working on research in school buildings for most part of my academic career, and just presenting some perspectives related to that, perhaps more focused on indoor air quality in schools and kind of pollutant removal technologies or possibilities by remediation, ventilation, and cleaning. I wanted to start with this figure already brought up by Lada, but still to keep in mind that indoor air quality as well as indoor environmental quality in schools is always impacted at least by these 4 factors, including the building site, the climate, regional, local conditions, the building type and year of construction, the materials used in it, and the air tightness, for example, as well as operation and maintenance, including heating, ventilation, air conditioning systems, cleaning, as well as the occupants and the use of the buildings, and also keeping in mind that the occupant perceived indoor climate may be different from what is objectively measured sometimes. Now I'm trying to move on. Let's see. I have the somewhere down here we tested this, but now I don't see the arrows again. I don't know where they disappear. Oh, here we go. Okay, did I go? Now several slides. Okay, so just related to the last slide, when we are talking about existing schools, there are limited possibilities for controlling pollutants and source control because we already have fixed the building site and type in a way. So I'll bring up some or present some principles and examples related to leading by knowledge, research-based pollutant reduction, control and management, including, as mentioned, mold remediation, some example related to filtration and air cleaning, ventilation, surface cleaning, pollutant avoidance, monitoring and feedback, and then perhaps referring to developing policies on different levels, including classroom, school, district, and even national level. And at the end, if I have time, I present an example of a successful renovation project, or actually district-wide project. So on the monitoring aspect, I wanted to bring up this WHO, so World Health Organization, developed standardized school survey methodology for monitoring progress towards their goals that included commitments to provide healthy environment in children facilities, ensuring that they are tobacco smoke free, implementing WHO indoor air quality guidelines, providing access to proper sanitation and enabling children to walk and cycle to schools. And as a part of this project, they conducted pilot surveys to test the protocols and evaluate necessary resources and cost, and produce preliminary data on exposures. And the parameters assessed in these pilot surveys included general characteristics of school building, student population, ventilation rate, NO2, formaldehyde, benzene, exposure to mold and dampness, and access to properly maintained and serviced sanitation facilities. The data collection methods are listed there. They may be a little outdated now. There are new methods perhaps, but overall it was based on this work assessed that these are important factors for school environment and indoor quality. Many of these are indoor quality related. And if I remember correctly, based on the pilot studies, most issues were found in those schools in areas providing adequate ventilation, issues related to dampness and mold, and also thermal conditions in the classrooms. So those are important things to consider. An example how this lead by knowledge principle could work is one of our studies in Finnish elementary schools, where we collected data from basically all Finnish elementary schools using questionnaires for school principals. And we found that inadequate ventilation was reported in 38% of the school buildings, dampness and moisture problems in 27%, and unsatisfactory temperature in 11%. And also we did some subsample with objective measurement data collection, including measured ventilation rates, and those results were quite well aligned with the principal recorded issues, where our current national guideline is minimum of 6 liters per second per person ventilation rate, and there is roughly 60% that are below that value, I believe. So we also collected data from students using questionnaires about their health and background variables, and found with these two data sets combined that these school level indoor environment quality indicator variables that the principals reported could explain a large part of the school level variation observed in the self-reported upper respiratory symptoms among students. So improving these conditions in Finnish schools could be effective already. We could correct large part of the school level variation in the reported symptoms. So it's just to question whether these same principles could be applicable in your project. I think it depends on the region or the country. Some of the issues are country specific, but overall, starting from the background information collection is always important. So you can think about ways to collect such background information that helps you to successfully design and complete your projects. I was involved with this was an European study on dampness and mold called HYTIA study, where the study was conducted in the Netherlands, Spain, and in Finland. And as a result, it was found that prevalence of moisture problems in school buildings were 20% in the Netherlands, 41% in Spain, and 24% in Finland. This was back in, I think, 2008 to 2012, so about 10 years ago. It was also found that the occurrence and severity of dampness and mold may vary across geographical areas, which can be partly explained by building characteristics. And also health effect studies were conducted and found that avoidance or remediation of damp and mold problems in school buildings may benefit students' respiratory health. I haven't worked a lot on filtration and air cleaning technologies, but just wanted to show you some examples here, mainly from the point of view of possibility to filter and clean air. If you have a school building like the figures on the left side from an African country, very open, leaky buildings, there is limited possibility to filter anything. You basically get everything that's outside, outdoors, also the indoors. Whereas if you have a relatively airtight building, such as the one in the middle from Finland, there are possibilities to filter outdoor air that is taken indoors. And but then perhaps the ventilation adequacy can be sometimes an issue. On the right-hand side is a picture showing some testing that we have been doing also to test effectiveness of portable ventilation equipment and also air cleaners. And in Finnish school buildings, and there it seems like they can be helpful in some cases, but it requires the building envelope to be relatively airtight because you can't really compete. You can't clean the entire outdoor air. And also we found that if the classroom has fully mechanical functioning ventilation system, the portable air cleaners or HVAC equipment can't really compete with that either. So I think maybe useful to consider in some relatively airtight buildings that are naturally ventilated. I have been involved with several studies looking at the associations between ventilation and health and academic performance. Here is some results from an early study done in the United States on the association between substandard classroom ventilation rates and students' test scores, where we found a linear association between substandard ventilation rate and these test scores. So it's an important parameter to think about when designing school buildings. We also have looked at the effects of temperature on test scores, and it's quite interesting. It looks like there may be an interaction there. So that the effect of ventilation is stronger if the temperature is higher, and this can be an additional challenge in certain climates, perhaps. And as it has been really brought up to quite strongly, ventilation also associates with illness absence, and especially in terms of, or since the COVID pandemic, there has been a lot of studies and even review articles emphasizing that ventilation is really important and it potentially decreases illness absence and mitigates the spread of infectious diseases. On the picture, there are different pathways how infectious disease can be transmitted. They can be transmitted by air or close contact, or also by indirect contacts to contaminated surfaces, which brings us to the cleaning aspects and the cleanliness. And there we can say that inadequate cleaning also leads to accumulation of dust and non-visible ecological niches, which can promote biological contaminants, including viruses. So here's an example of a study where we found a statistically significant association between the probability of weekly absence due to gastrointestinal illness and desktop ATP levels, which ATP is an indicator of biological contaminants on the surfaces that were monitored. It was also found that with respect to cleaning effectiveness, critical points to consider include the frequency of cleaning of different surfaces, especially high-touch surfaces, training the custodians and school personnel, as well as monitoring and feedback. And in this study, it was not possible to differentiate whether the microorganisms on the desktops were coming from prior occupants or by settling from the classroom air, and also the ventilation may play a role in that settling of the microorganisms on the surfaces. So there are some ways to practice kind of pollutant avoidance that I have called it here, including selecting materials, building materials, products, and trying to decrease emissions, chemical emissions. Also, pets and plants are sometimes, they can be found from schools, sometimes large numbers, and there can be, some people think they have positive effects, and some people think there are negative effects, but in any case, perhaps some sensitive individuals, they may be additional, not so beneficial to have them in the classroom if they are sensitive or allergic individuals. Then the other occupants, this issue came up strongly with the COVID pandemic, when we had to limit our close contacts with other people, the social distancing. It's not always easy to avoid contact with other people, and of course not always even necessary, but here on the right-hand side, there is an example of some data that we have collected with very accurate data from building occupants to individuals' positions in a school building throughout one day, and you can see that there's quite many possibilities of them being in close contact there, and overall very, very challenging topic to tackle, maybe in the future. Interesting area of research. There are new technologies that enable high-resolution monitoring and automatized feedback also in this area of indoor environment quality and indoor air quality. For example, I'm showing here some heat maps based on continuous monitoring results, and also based on occupant time consumption, and perhaps developing these technologies can help towards more personal indoor environmental quality, and kind of allow the occupants maybe some way of having better influence over their own personal environment. So I don't know if we have time to look at this example. It was actually just recently.
I think, yeah, just go ahead.
So we have been involved with this school district-wide renovation follow-up study over the past 6 or 7 years in the US in collaboration with the University of Tulsa and the University of Colorado Boulder, where we have followed up district-wide renovations, indoor environmental quality and illness absences. So the research in brief was such that there were over 50 schools in this one school district that had over 600 million bond renovation program where renovations were implemented in about 45 schools, multiple different projects where significant upgrades were done, including ventilation systems and improvements in cleaning effectiveness, as well as with the aim to conserve energy. So energy efficiency, energy retrofits were included. And we followed up the conditions before and after renovations, including thermal conditions, estimated ventilation rates using carbon dioxide monitoring, and also used monitoring of surface biocontamination by ATP. And we also had access to absenteeism data specifically related to illness and the type of illness. These data were collected by the school district, and they also provided us socioeconomic characteristics of the students over this whole 6 years follow-up period, including a total of 45,000 students. So the data provide high statistical power to assess changes in indoor environmental quality and association with absence to illness. And just summarizing some of the results, this table showing descriptive statistics of school level average, IEQ variables before and after renovation. You can see that the maximum CO2 concentrations decreased after renovations. Ventilation rates estimated by CO2 then consequently increased, now fulfilling the ASHRAE recommended minimum ventilation rate. Indoor temperatures remained pretty much the same before and after, but indoor relative humidity decreased some post-renovation, which could be related to the ventilation increase because these measurements were done mostly during the heating season, so outdoor temperatures were low. And also the ATP levels were decreased after renovations. And we assessed the number of days absent per school year by students, and we found that there were statistically significant associations between number of days absent and the renovation status. So the absence days due to respiratory illnesses were significantly decreased, as well as the absence days due to gastrointestinal illnesses. And in addition to these associations with the renovation status only, there were independent associations with higher number of days absent due to respiratory illnesses associating with lower ventilation rates and higher indoor temperatures and relative humidity, whereas higher number of days absent due to gastrointestinal illnesses associated also with higher indoor temperature, relative humidity, and ATP. So overall, encouraging results showing some health co-benefits after large-scale renovation of the school buildings. And the control button is once again lost here. There we go. So based on this example, we concluded that ventilation rates were significantly increased and biocontamination levels decreased after renovation, decreased number of days absent were associated with improved ventilation, cleanliness, and thermal conditions, and the results support maintaining good indoor environmental quality for better school health and reduced absence due to illness. It was also found to be helpful having continuous monitoring and feedback to reach and maintain the target levels. So I think these kind of endpoints are good to have and assess, and in this design challenge, maybe it's good to think about what are the target levels in your projects and how do you measure the success. Overall summary. Indoor environmental quality is frequently compromised in schools worldwide. Growing evidence is linking poor IEQ in the classrooms to student health and academic performance. And I think especially in schools and the education sector as a whole has a large potential for health and sustainable development, leading by example in providing healthier and more productive environments, while also reducing its carbon footprint. So I hope that the results of this challenge can be collectively used for developing classroom, school, district, national and international guidelines and policies in the future. I think that was my last slide, and I turn it back to Lada.
Thank you. Now, let's see if I can take it further. So, yeah, this was about indoor environment quality, indoor air quality, mostly what is important, what you have to think about. Actually, now I just take over for the end. Here is just sort of recap slide about what are the main factors of indoor environment quality, what we think about, and so yeah, as was said, air quality, thermal comfort, lighting comfort, and acoustic comfort. That's what you actually should reach, what you should go for in your renovation. I just put here just a few like numbers of each of these factors, which like sort of in general, which are used. But just go further. What actually we said that already a few times. Yeah, buildings are used by people, and how do people actually experience that indoor environment? How so? Maybe you are aware of that. If not, I just put here that slide which I like to use by my teaching, that actually people feel indoor environment with 4 from the 5 senses, main senses. And so, yeah, as you see here, like our skin, our touch, there we sense temperature, actually differences, humidity. With our eyes, of course, we see, with our ears, we hear, and with our nose, yeah, we smell indoor air quality, but actually not everything. There is very often that problem that we don't see that air which is bad, because we can smell tobacco smoke, but you are not allowed to smoke in schools. And sometimes we smell like that cleaning chemicals from like part of VOC, but most and sometimes we smell people odor, but not everything. So uh, it's but these are like senses how people experience buildings, and I think you as a designers, of course, have to take into account all of these senses, all of these parts. Uh, Here, actually, I made just few recap slides per that factor, where I put I think just some links and some ideas or some notes what you shouldn't forget to think about it. So let's say about the thermal comfort. I think nowadays I it's you should design building for based on an adaptive model of thermal comfort. And so it's when a change occurs, then people actually react. Before Ulla's part, I actually told you that in schools there is like different. It's very different that the teacher can react, and teacher is can control if there are any possibilities to control. Teacher can control in indoor environment. Children, they only take off a sweater if they have it. But okay, here just example of what you should think of, look at when you are going to design your building, and some links regarding to thermal comfort. Here I put something about lighting or visual comfort. Just ideas. Of course, lighting. When we speak about lighting, it's uh, about amount of light on a task during the day, or when we need artificial light. But it's also about brightness, about if there is glare or too high contrast. It's also about colors. So also about view. All these things actually should be taken into account in good design. And then we come to sound in indoor environments. I think I put here on the right that scale. I think all of you know these different types of drawings and scales that, we start, say, around 20 decibel with quiet forest, about 30 decibel, like reading rooms, classroom, and then it goes higher and higher. And of course, in a school, then in a building, you should think of materials which are going to be used there, not only qua sustainability, but also qua, let's say, acoustic, the absorption or reflection. So this is just a quick overview of indoor environment quality, what needs to be taken into account. And now I have here just a few recap slides about that, which I took from last week, that deadline 28 February. And here are competition challenges and focus points. But you know all these things, or you can find it somewhere else. And here I also copied the main point, this related to indoor environment quality and health, what you should focus on, what we just today try to give you just more info ideas. And yeah, what is here? We are looking. You shouldn't forget all these things about indoor environment quality, but we are looking here in this competition on innovations, your point of view, out of box thinking, advanced solution, hybrid approaches, etc. So now I am going to stop sharing, and if there are any questions, then you can raise virtual hand and then unmute and ask the question. Oh, there are no questions. Okay, Mari, do you want to say something according about the organization or?
No, that's it for us. And actually, you guys kept time very well, so that's good. Next webinar is next week, same time, same place. Not same place, not the same link. And the recording as well as the slides of this webinar will be updated on the website shortly, either today or tomorrow. And yes, that's it, I think.
Okay. Second webinar. Is there something now in chat? Thanks for your
the node. Yeah.
presentations. No. Okay. Well, so yeah, thank you everybody who joined us. Thank you, Ola, for doing this with me. and yeah, we are looking for the end of February. Then starts our work. Now is your students' work, and our work starts in March after we received our fantastic designs.